Hey everyone, it's Matt here with Nightrun Studio, and in this video, we're going to up our architecture game by adding a service locator pattern. This is going to be useful for a lot of in-game data persistence between scenes for things like opened chests and defeated enemies, but in this video, we're just going to show how to use it to increase our efficiency. Specifically, in our room transition manager, we're going to limit these expensive find calls that we're making within each of our room setups, so we no longer have to search through every object in the scene and can instead just ask our service locator to give us the references we need. Alright then, let's get started. Back in our project, let's right click, go to Create, Mono Behavior Script, and we'll create a service locator. Now we can begin by getting rid of the start and update methods, as well as the mono behavior. This is actually not going to be on a game object. In fact, what makes it so useful is that it will be a static class. So different objects in our scene can register themselves with this, and other objects can just query the service locator to find them. So let's start by creating our only variable here, which is going to be a private static dictionary. And this dictionary is going to hold a type, so a class like say our parallax manager, as well as the object that holds it. We'll call this services, and we'll just initialize it as a brand new dictionary. Now that will give us a number of errors. We need to make sure that we add the namespace using system, as well as using system.collections.generic, so that it can recognize both the terms type and dictionary. Alright then, now that we have a dictionary to hold all of these services, we need a way to register them. So we're going to make a public static void method called register t. Here the t just stands for the type of class we're registering. And anytime we call this, we need to pass in the service that we'd like to register. So when we call this for say parallax manager, we would register t, send along parallax manager. And now what this method is going to do is it's going to look in our services dictionary and create an entry of the type, say parallax manager, and it will just take the parallax manager we passed in and slot it in there as that entry. Finally, we're going to need a way to actually get our services out of here. And I'm not going to lie to you, this syntax gets a little weird. So this is a public static method of type t, meaning it's going to return a type or the class that we're looking for. We'll just call it getT. So for example, we could get parallax manager. And what it's going to do then is it's going to look in our services and try to get a value that matches that. So it will look for type of t, in this case say parallax manager, and then it'll spit out whatever it finds. Here we'll use a ternary operator, because what we want to do is if we actually find the thing we're looking for, we'll spit out that script, so now we have a reference to it. However, if it can't find the service, it'll spit out default, which is just an empty value. Now that we have our service locator, we're going to create our first service. So let's create a mono behavior script. I'm going to call this one room service, as it'll just hold a bunch of values in every room we enter so that we can access them easily. Now we'll just begin by getting rid of our start and update method, as usual. And this room service is going to hold 3 pieces of data for now. It's going to hold a public camera confiner provider reference, which we'll call provider. It will have a public parallax manager. Let's just call this one parallax. And finally, it's going to have a public list of spawn points. We'll call them spawns. And of course, this will create an error as list isn't in Unity Engine, so we need to add the using system.collections.generic namespace. Now this next part's really easy thanks to our service locator. All we want to do is make sure that whenever this room wakes up, this room service script is going to tell the service locator to register itself. And that'll just happen in each new room. Now our room transition manager will be able to get a hold of it. That said, the room transition manager is always looking for a spawn ID for where to place the player. So we're going to make a helper method here, a public spawn point method called getSpawn. This one is just going to spit out the spawn point where the player is supposed to appear. And so the transition manager can pass along the ID it's looking for, say spawn A or B, and this script will just look through all of its spawn points and it's going to return a spawn. Here we'll use a find method, and so it will return a spawn where the spawn's spawn ID matches the ID that our room transition manager is looking for. We'll show you how that works in just a moment. Okay, so to get our room service working, we'll just create an empty game object called room service. We'll make sure that we add the room service script. Now we just need to attach all of our things. So we'll grab the camera components for provider and the parallax manager. And for our spawn points, we just need to make sure that any spawn points in the room get dropped in here. In this case, I've only got 1. That said, while we're at it, I'm going to go to room 2. We'll drag it up here at the same time, and I'm just going to copy the room service into room 2. Of course, there'll be a mismatch between the different components, so we'll have to add the camera components from this scene to room service. and then make sure to get each of its spawn points. In this time around I've got 2, so I'm going to drag 2 of them over. At this point I'm just going to remove room 2. If you want, you can go ahead and do all your rooms right now, though I'm just going to do these 2 for starters. Then we can head into our room transition manager. Here, we just want to actually make this room service get used. So let's head down to our transition method. What we're going to do now is just before we call all of those 3 room setup methods, we're just going to do yield return null. This will cause our script to wait 1 frame, which will give the new room time to register its room service. At this point, we're just going to ask for that room's room service. So we'll make a room service reference called service and just ask the service locator to get the room service for that room. At this point, we'll have to make sure to pass that service along to each of our setup methods, and then we can head on down below. At this point, we can take our setup room method and actually not just make it more efficient, but also make it a lot shorter. We can get rid of these top 2 lines altogether, as we no longer need to do that expensive find check. And now we'll just change this if the string is null or empty, get rid of the not, because if it's empty, we're going to return. That means we're in the main menu or something like that, and we don't have any room setup to do. At this point, we can copy that transform position line and delete all of the rest. At this point, our method becomes dead simple. We're just going to get the spawn point, we'll call it spawn to use, for where the player is going to go, here by asking our room service to get spawn, and we'll just pass along the spawn ID that we're looking for. Here we'll do a null check just to make sure we don't get errors, and as long as it finds the spawn point, it'll set the player's transform position to be equal to the transform position of the spawn to use. Now in our setup camera confiner, we can once again get rid of the expensive find first object call, and instead just do a simple check here. If our room service actually has a confiner provider, meaning it's not null, then we'll just tell the camera manager to set its confiner to be equal to the room services provider's confiner. And then we'll do essentially the exact same thing in our reset parallax. We're just going to make it so that if our service actually has a parallax manager, then we'll tell the service's parallax manager to initialize itself. Now this is the moment where I noticed that I forgot to update my signatures on my methods, so I'm just going to make sure that each of them is expecting a room service to get passed in, which we'll just call service. I'll just copy and paste that into each of these, and then we're good to go. All right, back in Unity, we're ready to give this thing a whirl. Now when we get in our scene, it should fade in like it normally does. We should transition to the first scene, no problem. However, when we try to go back, you'll probably find that we're getting this weird glitchy double firing happening. And all that's going on here is that we're actually calling our transition method multiple times each time we hit the collider. You'll probably find that it occasionally works properly and occasionally double fires. It's going to be really inconsistent, so let's fix that. So to protect ourselves from multi-firing when we hit this, we're just going to add in a gate, a private bool called isTransitioning. Then whenever we enter a room, we'll just say if isTransitioning is true, we're just going to return, meaning we don't want to fire this again. That way it can only fire once. Now as soon as we are calling transition, we want to make sure that isTransitioning gets set to be true. And then down at the bottom, we want to make sure that once this method is completely finished, we unlock it by making isTransitioning go to false. All right, so now when I get in my game, I can go back and forth between the scenes, no problem, and we're no longer getting that double fire or any problems like that. However, right now I'm being very patient. And what happens if I try to go back and forth really quickly? You'll notice that we run into this. Now what's happening here is that we're in the middle of running our transition method when we try to run it again. But because isTransitioning is true, it's locked and we can't re-enter. So the player gets to the other side of the collider and he can't trigger it anymore because he's already passed it. There's a couple little things we could do to minimize this. We could make our fade in time half, which would create a smaller window where the problem could happen. That said, even doing this, there's still going to be a window where the problem could happen. So I'm going to actually fix this by locking my player instead. Now at the very top here, I'm just going to create a public bool called isControlLocked. We'll then just scroll way down to the bottom where we take in all of our different movement inputs, and in onMove specifically, we'll just check to see if isControlLocked is true, and if so, we're just going to make our input equal to a vector 2.0, so nothing, and return before we can change that value by reading the actual inputs. While we're at it, we also might want to pause things like attacking and jumping, and in these cases, we'll just make it so that if isControlLocked, we just return, meaning we don't read any values. The last thing we need to do then is just make sure that this player script actually gets registered with our Service Locator. So in Awake, we'll just tell the Service Locator to register a player reference and we'll pass along this specific instance of the player. Now then, back in our room transition manager, whenever we start a transition, we'll first of all set is transitioning true, and then we'll just get our player reference. We'll do this by asking the service locator to get the player reference, and then we can just simply tell the player that is control locked should now be true. We can then just copy this and head all the way down to the bottom of our transition method and just give the player control back once we're done executing this coroutine. So now when we get in the game, we can go back and forth as many times as we want, and the fade works great. The player's locked, so we can't head back before it's ready, and everything's working out pretty good. The only thing is, I'm noticing that the lock feels like it lasts just a little too long. I feel like I should have control of my player back, but I don't yet. I also don't love the fade in that happens as soon as we start the game, and I'd like to get rid of that. All right, so first off, I'm just gonna grab the is transitioning and the player lock here. I'm gonna cut them out. And I'm actually just gonna move them up a little bit so that before we start our fade in, we give control back to the player. That'll just make it feel a little more natural as we'll be able to move while the room fades in. The one other thing we're gonna do is just up at the top here, we wanna make it so that our screen fader doesn't fade in every single time. So if we're, say, coming from a menu or just starting our game up to test. So here we'll just check our spawn ID, and if it's not null or empty, remember it will always be null on start, and it will be not null, meaning we actually want the fade to happen, anytime we actually load a scene in a transition. So this will stop us from getting that automatic scene fade, and now we'll only get it if we're actually transitioning between scenes. I'm actually just gonna copy that and paste it down here at the bottom so that we'll do the same thing for our fade back in, meaning we'll only fade in if we're actually transitioning. All right, with that done, we can run our final test. Now things are looking much better. We're getting a nice smooth fade. We're getting all of our hookups done. We're only briefly losing control of the player, and it's actually feeling pretty good. All right, in our next video, we're gonna actually add a Metroidvania style minimap. Hope to see you in that video. Until then though, this is Matt with Nightrun Studio. Cheers.